In section 2, we're going to take a look at the triangle sum and triangle exterior theorem. So the first one is the triangle sum or angle sum theorem, which states that the sum of the measures of the angles of a triangle is 180 degrees, which I did mention in section 1 when I was talking about classifying triangles by their angles. So that tells us in the triangle here is that the measure of angle W plus the measure of angle X plus the measure of angle Y is going to equal 180 degrees. So let's go ahead and use this to find missing angle measures in triangles. So if we look at our first picture, we have a triangle with 43 and 74 degree angles and missing angle 1, and then our second triangle has angle 79 degrees with missing angles 2 and 3. The easiest angle to solve for first is angle 1, since in the triangle it's in we have 2 out of the 3 angles. So we know that 43 plus 74 plus the measure of angle 1 is going to equal 180 degrees. So I do 43 plus 74, we get 117. So 117 plus the measure of angle 1 is going to equal 180. Subtract 117 from both sides, and we get that the measure of angle 1 equals 63 degrees. Next, we want to solve for the measure of angle 2. Well, angle 1 and angle 2 are vertical angles, and as already discussed, vertical angles are congruent, which means they have the same measure. So that tells us the measure of angle 2 is also 63 degrees. So that just leaves us with finding the measure of angle 3. But now that we know 2 of the 3 angles in that second triangle, we know that 63 plus 79 plus the measure of angle 3 is going to equal 180 degrees. 63 plus 79 is 142 plus the measure of angle 3 equals 180. Subtract 142 from both sides, and we get that the measure of angle 3 equals 38 degrees. In our second angle, we need to solve for 4 angles. The easiest angle to solve for first is angle 2, since we know 2 out of the 3 angles. So we know the measure of angle 2 plus 50 plus 70 equals 180. 50 plus 70 is 120. Subtract 120 from both sides, we get the measure of angle 2 is 60 degrees. We also have the angle 1 and angle 2 are vertical angles, which means their measures are the same. So we know the measure of angle 1 is also 60 degrees. Now we can solve for the measure of angle 3 using the triangle sum theorem. So 60 plus 65 plus the measure of angle 3 is going to equal 180. 60 plus 65 is 125. Plus the measure of angle 3 equals 180. Subtract 125 from both sides. We get the measure of angle 3 is 55 degrees. That just leaves us with angle 4. And angle 4 forms a linear pair with angle 1. It also, if you look at a different line, forms a linear pair with angle 2. Now, considering angle 1 and angle 2 have the same measure, it doesn't matter which one we use to help us solve for the measure of angle 4. So we'll get 60 plus the measure of angle 4 equals 180. subtract 60 from both sides, and we get the measure of angle 4 is 120 degrees. And we've solved for all 4 angles. Next, we want to actually prove the triangle sum theorem. It is a theorem, which means there is a proof that shows why the theorem works. So in order to do this, I'm going to draw a picture. We have triangle ABC, and I'm also going to draw a line through A with point E on it that is parallel to our side BC. So what I'm going to actually tell you what we're given. We're actually going to be given 2 statements. One of them is that ABC is a triangle. The second is that line E passes through A and is parallel to BC. It's also going to be given information for us to help us with our proof. I'm also going to go ahead and label the interior angles of the triangle to make it easier in the proof, along with the 2 angles at the top along line E. First thing I'm going to realize is that angles 1, 4, and 5, because E passes through point A, that's a straight line. So our angles 1, 4, and 5 have to add to 180 degrees. So the measure of angle 1 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees. And the reason is going to be the definition of a linear pair. Now, normally a linear pair involves 2 angles adding to 180 degrees, but we are allowed to use 3 angles because we know it is a straight line. The other thing I'm going to use is the fact that line E is parallel to BC. Because E and BC are parallel, I can consider my side AC as a transversal, in which case we would have that angle 2 is congruent to angle 4, and we also have that angle 3 is congruent to angle 5. And the reason behind that would be that they are alternate interior angles, in which we proved that theorem. So alternate interior angles theorem. And when 2 angles are congruent, their measures are equal. So I can then say that the measure of angle 2 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. And that comes from the definition of congruence. Okay. Now, because angle 2 equals angle 4, the measures are the same, and the measure of angle 3 equals the measure of angle 5, I can substitute that into my linear pair statement. So add another line here. And I now have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees by substitution. And angles 1, 2, and 3 are the interior angles of my triangle, and I have proved that the sum of the angles of a triangle is 180 degrees. We also have something called the third angle theorem. And what that theorem states is that if 2 angles of one triangle are congruent, to two angles of a second triangle, then the third angles of the triangles are congruent. This theorem comes directly from the triangle sum theorem because there's only one possibility for that third angle to be if the other two are congruent in order for them to add to 180 degrees. So we have angle A is congruent to angle D, angle B is congruent to angle F, which then gives us that angle C has to be congruent to angle E. So lastly, we're going to talk about the exterior angle theorem. And an exterior angle is formed by one side of a triangle and the extension of another side. So if I look at the picture I have drawn below, I extended side XZ so now I have a point P outside, so I have an exterior angle YZP. Remote interior angles are the angles of a triangle that are not adjacent to a given exterior angle. So if my exterior angle is YZP, the interior angles that aren't next to it would be angle Y and angle Z, since angle YZX is the adjacent one. So both of those help us find the measure of an exterior angle, which is equal to the sum of the measures of the two remote interior angles. So what that means is that the measure of angle YZP, which is my exterior angle, equals the measure of angle Y plus the measure of angle X, since they are the remote interior angles to the exterior angle. So let's go ahead and look at a couple of examples. So we want to find the measure of each angle. So in our first picture, we want to find the measure of angle A, given the measure of angle B is 20 degrees, and the measure of angle BCD is 56. Well, angle BCD is our exterior angle, which means that the measure of angle BCD equals the measure of angle A plus the measure of angle B, which means the measure of angle A can be found by taking the measure of angle BCD, which is 56, and subtracting the measure of angle B, which is 20. So the measure of angle A is 36 degrees. So next we want to find the measure of angle DCB, which is the exterior angle. So the measure of angle DCB is found by adding the measure of angle A plus the measure of angle B, which are the remote interior angles, which have measures of 55 and 27. So the measure of angle DCB is found by doing 55 plus 27, which means the measure of angle DCB is 82 degrees. So next we have a find the error problem. It says Naji and Kara are discussing the exterior angle theorem. So we have a picture here. Naji says that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And Kara says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 is 180. We want to know who is correct. Well, if I remember the exterior angle theorem, exterior angle is found by adding the two remote interior angles, which are angle 1 and angle 2. So that would mean that Naji is correct because angle 1 and angle 2 are the remote interior angles to the exterior angle, which is 4. Carr kind of has a misconception about the triangle sum theorem. Carr's statement would be true if she said the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees, but still not correct when discussing the exterior angle theorem. Next, we have that BA and BC are opposite rays, and the measures of angle 1, angle 2, and angle 3 are in a 4:5:6 ratio. Find the measure of each angle. So because BA and BC are opposite rays, they form a line, which tells me the measure of all 3 angles equals 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to equal 180 degrees. They form a straight line. Now I want to use that ratio. So I can add a variable and say that angle 1 is 4x, angle 2 is 5x, and angle 3 is 6x. That is what the 4:5:6 ratio tells me. It just adds a variable to let me know that that's the relationship between those angles. So in my equation here, I can replace the measure of angle 1, the measure of angle 2, and the measure of angle 3 with 4x plus 5x plus 6x equals 180, and this allows me to solve for the value of the variable so that I get the correct ratio for the measures of those angles. So 4x plus 5x plus 6x is going to give us 15x equals 180. Divide by 15, and we get that x equals 12. So x is 12, but that's not the measures of our angles. So the measure of angle 1 is 4 times x, so 4 times 12, which is 48 degrees. The measure of angle 2 equals 5 times x, so 5 times 12, which is 60 degrees. And the measure of angle 3 equals 6 times x, which is 6 times 12, which is 72 degrees. And if I were to check by taking 48, 60, and 72, putting them all over 180 and simplify them, I would get the ratio 4:5:6. The last thing we're going to do is a proof. And we are going to prove the triangle exterior angle theorem. That is that the measure of an exterior angle is the sum of its remote interior angles. So basically, we want to prove in our picture that the measure of angle BCD equals the measure of angle A plus the measure of angle B. So our first statement is going to be that ABC is a triangle. That is going to be our given information. It allows us to make a couple assumptions that are really important. The first one being that because our triangle ABC is a triangle, it tells us what the sum of the interior angles has to be. So it tells us that the measure of angle A plus the measure of angle B plus the measure of angle ACB is 180 degrees. And that's from the angle sum theorem, which is what we started this section talking about. We also know that angles ACB and angles BCD form a linear pair, which means the measure of angle ACB plus the measure of angle BCD is 180 degrees as well. And that would be from the definition of linear pair. Now we have two statements both equal to 180 degrees, so by substitution, I can set them equal to one another. So the measure of angle A plus the measure of angle B plus the measure of angle ACB equals the measure of angle ACB plus the measure of angle BCD. And the reason would be substitution. If I look at both sides of my equation, I see both of them have the measure of angle ACB, which means if I were to subtract it from both sides of the equation, it would cancel. And when I do that, we end up with the measure of angle A plus the measure of angle B equals the measure of angle BCD. The reason would be the subtraction property. And so that I want to prove the measure of angle BCD equals the measure of angle A plus the measure of angle B, and I have the reverse of that statement, I can rewrite it as the measure of angle BCD equals the measure of angle A plus the measure of angle B, and that would be the symmetric property. I'm allowed to reorder what's on each side of the equal sign as long as it's still the same statement. So we've now proved the triangle exterior angles theorem. So let me know when you're completing the assignment if you have any questions about either the angle sum theorem or the triangle sum theorem and the triangle exterior angle theorem.